Welcome to the Agentic AI Podcast, the show where we explore these intelligent systems that are, well, autonomously performing tasks, making decisions, and really starting to transform industries.
It's happening fast.
It really is. And today we're diving into a challenge that's becoming, I think, increasingly critical. As these intelligent agents multiply across your enterprise, how do they actually talk to each other? How do they collaborate?
That's probably the central question right now for anyone in this space, especially for you if you're an AI enthusiast or a decision maker looking to unlock that next level of automation and efficiency. Understanding this landscape of agent communication, well, it's not just important, it's absolutely fundamental.
Right. And that's really our mission for this deep dive. We're going to explore two pretty pivotal frameworks shaping the future here.
Right.
The LangChain Agent Protocol and this ambitious Open Agents initiative, especially through the AGNTCY collective.
Yeah, we'll unpack what they are, look at how they differ, and maybe most importantly, try to help you figure out which one might be the better strategic fit for your specific needs.
Exactly. We want to give you the clarity to make those informed choices, understand the why behind these standards, and hopefully arm you with some, concrete insights for your next big AI project.
Sounds good. Let's jump in.
Okay, so let's unpack this a bit. Agentic AI, it's ushering in this new era, right? Everything from, say, customer support bots to really complex workflow management. But why is standardization specifically so critical right now? Why can't these agents just, figure it out themselves?
Well, it really boils down to a fundamental issue that, honestly, many organizations are probably already hitting. As you get more AI agents, maybe built using different frameworks like LangChain or Autogen or Crew AI, as they proliferate, they often really struggle to communicate effectively with each other.
Oh, okay. So like a Tower of Babel, but for AI agents.
Sort of, yeah. Imagine a sales agent built on one platform that just can't update your inventory system built on another. Or a customer service bot that needs to trigger a supply chain alert but can't talk to that system. This kind of fragmentation, it leads to these silos of intelligence.
Right, and missed opportunities where they could be working together.
Exactly. Missed synergy, and ultimately, it puts a real drag on achieving that comprehensive end-to-end automation everyone's aiming for.
So the why then is really about enabling these agents, maybe even from different teams or different vendors entirely, to just work together smoothly.
Precisely. Standardized frameworks, they ensure agents can discover each other, communicate effectively, and crucially, orchestrate complex multi-step tasks. And they can do this regardless of their underlying architecture or even the specific LLM, the large language model they're using.
Okay, so it's not just a nice to have.
No, definitely not. It's vital if you want to build robust multi-agent systems that can actually handle the nuanced real-world tasks that drive genuine enterprise value. These frameworks, they provide the essential structure, right? They manage the agents, define the interactions, ensure reliable performance. That's absolutely critical if you want to scale these LLM-based AI systems across all the diverse, complex use cases you find in an enterprise.
Got it. So the frameworks are kind of the essential plumbing, the glue holding it all together. Now, let's talk about a key player here, the LangChain Agent Protocol. LangChain itself has been a real leader in LLM-based apps. What's their specific approach, their core proposition for agent communication?
So the LangChain Agent Protocol is essentially LangChain's own standardized interface for agent communication. Its primary purpose is really to codify a set of framework-agnostic APIs specifically for serving these LLM agents effectively in production environments.
Okay, framework-agnostic APIs, but developed by LangChain. And how does it work? What are the main parts?
It focuses on three core components, things that are pretty fundamental to how agents operate and interact. They call them runs, threads, and store.
Runs, threads, and store. Okay, can you maybe break those down? What does each one actually do? Maybe with a quick example.
Sure. Think of runs as APIs for just executing an agent for a single self-contained operation. It's stateless, meaning each execution is kind of a clean slate.
Okay, like a one-off task.
Exactly. For an enterprise, that could be ideal for, say, a quick data lookup or generating a simple report where you don't need memory from past interactions. Then you have threads. These are the APIs for managing multi-turn interactions.
So for conversations or steps in a process.
Precisely. Crucial for conversational AI, obviously, but also for those sequential workflows where an agent needs to maintain context over multiple steps or even over time. Imagine a complex approval process, maybe for a loan. An agent needs to remember decisions made across several steps, maybe even days apart. Threads enable that persistence, that memory of the workflow.
Which avoids starting over, crucial for compliance too, I bet.
Absolutely. And finally, there's the store. This provides APIs for longer-term memory. It lets agents persist and retrieve information across completely different sessions or interactions.
So that's for learning, remembering preferences.
Exactly. Vital for true learning and adaptation over time. Maybe remembering a customer's preferences over months or a specific project's history.
That breakdown makes a lot of sense. Runs for one-offs, threads for sequences, store for long-term recall. So if I'm a developer, maybe already deep in the Python world, especially using LangChain, what are the immediate strengths I'd see using this protocol? Sounds like the integration would be pretty smooth.
You hit the nail on the head. For existing LangChain users, or anyone in a Python-first environment, the integration is seamless. It plugs right into LangChain's extensive toolkit. Plus, a big advantage is its tool abstraction.
Tool abstraction, meaning?
Meaning developers can focus more on the agent's logic, the decision-making, rather than getting bogged down in the nitty-gritty details of how each external tool, like a CRM or a specific database, is actually implemented. The protocol handles that interface layer.
That sounds powerful. Less boilerplate, more focus on the AI part.
Right. And of course, the prompt-driven execution is a major strength. It really leverages LangChain's capabilities in prompt engineering, crafting those precise instructions for the AI model. This gives you a lot of flexibility and power in defining how the agent behaves.
Okay, sounds good. But there's always a flip side, isn't there? What are the potential drawbacks or maybe limitations someone might run into with the LangChain Agent Protocol?
Well, that deep integration with LangChain, while a strength for many, can also be its main limitation. It means it's pretty tightly coupled to the LangChain ecosystem.
So less flexible if you're using other frameworks.
Potentially, yes. It might limit compatibility or just make it harder if you're trying to integrate with non-LangChain frameworks or maybe bespoke tools you already have in your enterprise stack. And also, its design is, quite opinionated.
Meaning it reflects LangChain's way of doing things.
Exactly. It reflects LangChain's specific architectural choices, which is fine, but it might not align perfectly with every single use case or, every organization's preferences, especially if you have a really diverse, heterogeneous AI landscape already.
That paints a clear picture. Powerful within its ecosystem, maybe less flexible outside it, and comes with its own design philosophy. Okay, that leads us nicely to the other side of the coin. The Open Agents initiative, particularly through this Agentic AI collective. This sounds much broader, aiming for something they call an Internet of Agents. That sounds huge.
It is. Agentic AI's vision is genuinely ambitious. It's aiming for a fundamentally open, interconnected future for AI agents. Think about how the internet works for information. They want something similar for agent collaboration.
An Internet of Agents. Wow. What are the core ideas behind that?
It's really built on three main pillars designed to tackle that fragmentation problem we talked about earlier. First, interoperability.
Making sure agents from different vendors, different frameworks can actually work together.
Precisely. Like different web browsers all accessing the same internet. Second, decentralization. They want to foster an ecosystem where agents can operate independently but still collaborate securely when needed, rather than everything being controlled by one central company or platform.
Avoiding lock-in, basically.
Yeah, and that ties into the third pillar, being LLM agnostic. Supporting a wide variety of large language models is key. It avoids vendor lock-in at the model level and lets you use the best model for any particular task.
Okay, interoperable, decentralized, LLM agnostic. That really does sound like a foundation for something truly open. How does the underlying architecture work? What makes that possible?
Well, at its core, Agentic AI uses decentralized tech for agent identity. Think of it like giving agents verifiable digital passports so interactions are secure and trustworthy across this open network. They've also developed something called the Open Agent Schema Framework, or OASF.
OASF, what's that?
It's basically an extensible data model, a way to describe agent attributes, and crucially, it leverages principles from the Open Container Initiative, OCI.
OCI, like Docker containers, making software run the same everywhere.
Exactly that idea. Applying that kind of rigor to defining agents means they can be truly portable and universally understood no matter where they run or who built them. Then there's the Agent Connect Protocol, ACP. That's the bit that facilitates the actual secure and efficient communication between agents, allowing for that cross-framework collaboration.
So identity, a common description format, and a connection protocol.
Right. And the whole design prioritizes scalability and standardization. It's built using cloud-native approaches designed to support a potentially massive number of agents with consistent data representation, ready for enterprise scale.
It's fascinating how Agentic AI seems focused on event-driven communication, graph-based workflows, tool-agnostic actions. It really does sound like they're building the comprehensive infrastructure for these future multi-agent systems. Am I reading too much into that, or is that the real goal?
No, you're not overstating it at all. That is the ambition. They are trying to lay down the foundational plumbing for a truly distributed, collaborative AI future.
What are the biggest challenges in actually achieving that, though? It sounds incredibly ambitious.
Honestly, the biggest hurdles are probably widespread adoption and that classic chicken and egg problem of network effects. For an internet of agents to really take off, you need a critical mass of developers, vendors, and enterprises building agents that actually use these protocols.
Getting everyone on board.
Exactly. Aligning a whole industry is a massive undertaking, even when you have backing from big tech players. But I mean, if they succeed, the potential for seamless, even cross-organizational automation is just transformative.
Okay, so let's bring this down to the ground level.
Yeah.
For you, the listener, the enterprise decision maker, what does this all mean? Let's put LangChain Agent Protocol and OpenAgent's Agent ACY side by side. If you're crafting your AI strategy, how do you choose?
Okay, let's do a direct comparison across a few key areas. First, architecture design. As we said, LangChain's protocol has a, let's say, narrower focus on standardizing agent execution and memory runs, threads, store. It does that well within its scope. AGNTCY, though, is going for a much more comprehensive infrastructure. Identity, schema, connection protocols, the whole foundation.
A broader base versus a more focused solution? What about extensibility, modularity? Thinking about future-proofing.
That's a really important point. LangChain's protocol is extensible, but it's quite tightly knit with the broader LangChain ecosystem. That can limit its modularity if you need to easily plug in components from other AI frameworks or maybe your own internal tools.
Where is Agent ECY?
Agent TCY is designed from the ground up to be highly modular and extensible. It wants you to plug in diverse tools and services from different providers. That flexibility naturally extends to tool ecosystem support too. LangChain is strong with its own tools, but obviously limited outside that. AGNTCY is deliberately vendor agnostic, trying to encourage a wide-open ecosystem where any agent could potentially connect to any tool.
That sounds critical for large companies that probably already have a mix of technologies. How about deployment? Where can these agents actually run?
Good question. For deployment flexibility, LangChain's protocol can run in various places, but often you get the most benefit, or it might even require LangChain's specific infrastructure. AGNTC, being cloud-native and built for scale, is designed to work across different public clouds, hybrid setups, even on-premises. That's a big plus for organizations with complex infrastructure needs.
And finally, what about the community and how these things are governed?
Right. Community support and governance. LangChain has a strong, active community within its user base, and its governance is more centralized with LangChain, the company, which can mean faster decision-making sometimes. AGNTCY, on the other hand, is backed by this coalition of big tech companies, Cisco, Dell, Google Cloud, others, and aims for a decentralized governance model. The goal there is broader consensus, industry-wide buy-in, fostering a truly open standard.
Okay, that comparison is really helpful. It brings us to the crucial use case fit and enterprise applicability. Let's start with the LangChain Agent Protocol. What kind of organization, what kind of project is it really the best fit for?
I'd say it's ideal for teams that are already heavily invested in LangChain, maybe using LangChain extensively for other LLM applications, or for teams looking for a quick way to standardize agent communication within their existing LangChain stack.
Maybe smaller teams or projects focused on speed within that ecosystem.
Yeah, think maybe a startup iterating quickly on a product, likely with a Python-first stack. LangChain lets you hit the ground running there with fewer external dependencies. You'd use it for rapid prototyping of agent systems, building those conversational agents that really benefit from LangChain's prompt engineering, and easily integrating with all the tools LangChain already supports, like for data retrieval or calling APIs. It's best if your priority is fast development within that single coherent ecosystem.
Okay. And then open agents via AGNTCY. Who is that really built for? What problems does it uniquely solve?
Open agents and AGNTCY, that's really geared towards large enterprises, particularly those with complex, heterogeneous AI environments, maybe multiple teams using different tools, different clouds. They're the ones who really need that scalability, robust security, and deep interoperability across different systems and vendors.
So if you've got AI projects popping up in different departments using different tech.
Exactly. Or if you know you'll need to integrate agents from various third-party providers down the line. Agent TCY is trying to be that universal adapter for your entire AI landscape. It's for organizations aiming for modular, multi-vendor agent systems that can scale across different clouds and integrate with a huge variety of tools.
What kind of applications?
Think large-scale enterprise automation spanning multiple departments. Or really complex multi-vendor agent orchestration, like in supply chain management, where an inventory agent in one system has to talk to a logistics agent in another. Or maybe advanced customer service automation, pulling data from lots of different internal and external sources. It might take a bit more planning upfront, perhaps, but the goal is immense future flexibility and avoiding getting locked into one vendor's world.
Right, that makes sense. Now, this is where it gets really interesting, I think. How do platforms actually use these standards in the real world? You mentioned Lowtouch.ai, a no-code agent orchestration platform. How does a platform like that actually benefit from something like AG and PCY?
Lowtouch.ai is a great practical example. By adopting open, interoperable standards like those promoted by AG and TCY, Lowtouch.ai can achieve something really powerful. It can allow its users, even business users without coding skills, to connect and orchestrate agents that might come from completely different vendors or be built on different frameworks.
So it breaks down those silos for the end user.
Precisely. It massively enhances the platform's versatility and its appeal, especially to enterprises that, as we discussed, likely already have diverse AI ecosystems. Supporting a wide range of tools and services becomes a key selling point.
And it must help with scalability and deployment too, right?
Yeah.
Especially for a no-code platform needing to work everywhere.
Absolutely. It ensures they can offer scalability and flexibility for deploying these orchestrated agents across different clouds or even on-prem environments, aligning with where their enterprise customers actually operate.
It feels like that no-code approach plus open standards really democratizes this stuff.
It does. Lowtouch.ai's approach really resonates with that Internet of Agents vision from AG and TCY. It makes sophisticated multi-agent systems much more accessible, even for non-technical folks, while still meeting the tough security, scalability, and integration demands you see at the enterprise level. It's a powerful example of how these underlying standards enable real-world solutions that deliver actual business value.
This whole discussion really underscores how rich and, frankly, complex the agentic AI space is becoming. Beyond just these two core protocols, there are other related concepts and distinctions floating around that decision makers probably need to be aware of to navigate effectively.
Absolutely. There's a lot of terminology, and sometimes the distinctions are subtle but important.
Okay, so maybe we can quickly clarify a few that often come up. For instance, you sometimes hear about crew AI versus LangGraph. If I'm designing a system, how do I know which approach fits? Is it about teamwork versus control?
That's a good way to put it, actually. Crew AI is specifically designed for collaborative multi-agent systems. It really emphasizes agents working together as a team, delegating tasks like a human crew would tackle a complex project. LangGraph, on the other hand, is LangChain's own lower-level orchestration framework. Yeah, it focuses more on graph-based workflows. Think finite state machines. It gives you very precise, granular control over the steps an agent takes, the transitions between states. So if that kind of explicit step-by-step control is paramount, LangGraph is your tool. If it's more about emergent collaboration between specialized agents, Crew AI is probably a better fit.
Okay, that's helpful. Teamwork versus precise flow control. Now, what about LangChain versus AutoGen? We mentioned them earlier. They both help build LLM apps, but what's the key difference for someone choosing a framework?
Right. LangChain, as we've established, is this comprehensive toolkit for a broad range of LLM applications, including agents. It's strong on tool abstraction, prompt engineering, kind of a full-stack solution for LLM app dev. AutoGen, which comes from Microsoft Research, has a slightly different focus.
How so?
It's particularly well-suited for creating conversational agents that excel at interacting with code and APIs. It has a strong emphasis on things like code generation, code execution, and enabling agents to actually converse and debate with each other or with humans to solve problems, especially technical ones.
So if my agents need to write and run code, AutoGen might have an edge.
It could well be the sharper tool for that specific job, yes. Whereas LangChain offers perhaps a broader canvas for general LLM application development, including agents.
Got it. One last clarification. We've talked a lot about memory and tools. Can you just briefly distinguish between agent memory protocols and toolchain APIs? They sound connected but different.
They are definitely connected but serve distinct purposes. Agent memory protocols, like LangChain store component or similar concepts, define how agents store, retain, and retrieve information over time. This is all about enabling learning, adaptation, maintaining context, the agent's internal knowledge base, if you like.
And toolchain APIs.
Toolchain APIs are focused entirely on how agents interact with the external world, external tools, services, databases, other APIs. They're about action execution, integration with other systems, how the agent reaches out to do things. So one is about internal knowledge and learning over time. The other is about external action and integration right now.
Internal versus external. That clarifies it perfectly.
Okay.
Okay, wow. We have covered a lot today looking at the LangChain Agent Protocol and the Open Agents Initiative through AGNTCY.
We have, and I think the key takeaway is that the choice between them isn't really about one being objectively better across the board.
Right. It's much more about alignment, isn't it? Alignment with your specific use case, your existing tech stack, your team's skills, and maybe most importantly, your long-term strategic vision for automation in your enterprise.
Exactly. There's no single right answer that fits everyone, and it raises a really important point. As this field of agentic AI just keeps evolving at this incredible pace, truly understanding these foundational frameworks, their strengths, their weaknesses, their nuances, it's absolutely crucial.
Crucial for actually building systems that are robust, that can scale, and that are genuinely interoperable. The kind that will actually deliver on the huge promise of AI-driven automation and transformation.
Couldn't have said it better myself.
So let's leave our listeners with a provocative thought to chew on. Thinking about your own organization. What if every single AI agent you deploy, regardless of who built it, what framework it uses, what LLM powers it, what if they could all seamlessly discover each other, communicate, and orchestrate tasks together?
Interesting question.
What previously impossible automation could that unlock for you? What complex, currently siloed problems could your organization suddenly solve if that barrier just disappeared? How might that fundamentally transform your operations?
That really is the multi-billion-dollar question, isn't it? A truly exciting prospect to consider.
It really is. Well, thank you so much for joining us on this deep dive for the Agentic AI podcast. As always, stay curious and keep exploring the future of intelligent automation.